Just a little disclaimer at the beginning here. I got a little bit ranty and ravey in this near the end, so I had to chop it down a little. Sorry about the jumpy edits there. I'm not in the business of calling people out. I just want this community to move forward and development to keep happening. Also, in the where do we go from here section, I get a little bit into where I'm naming some of the boards that are available, and I obviously there are many, many more that I didn't mention. I will mention them in a later video, so don't jump down in the comments and be like, what about smart ramps? What about this and that? What about this MKS thing? Because I will talk about them in the future. And this outro to the ramp series is really an intro to the rest of the 32-bit series. So stay tuned for that. If it's something that you're interested in, I'll be putting a lot of videos out. So without further interruption, I present to you the video. So we've done 5 videos on the Humble Ramps board. And honestly, I probably could have done another 5 or 10 more, but I wanted to make sure that I hit the basics so that there was an opportunity for me to present the thought behind each of those things and some of the math and the difficulties involved. Get people headed in the right direction without spoon-feeding them information. To get those tools in their hands, but give them the opportunity to think about their choices. So let's do a little wrap-up here. Kind of a retrospective post-mortem and where do we go from here type of a thing. So I guess the first thing to talk about is why is the ramps board so popular? I can think of a lot of basic reasons. First off, they're super cheap. It wasn't originally super cheap, but it had the benefit of getting adopted by Chinese manufacturing and they made them accessible to the masses. They're flexible. They might not have all the features of some of the bigger boards, but they have a lot more than you actually need to get a basic 3D printer running. They're modular, and that's a big one. I'm not going to talk crap about some of the nice boards that are out there, but they're not modular and they're not flexible, and that's fine for a completed printer, but it's a completely different market than people that are trying to make a flexible experimental machine or that are trying to develop firmware or drivers or whatever for various peripherals and that sort of stuff. Many of those boards, they kind of lock you into a particular ecosystem with what they do and don't support, with displays and sensors, SD card readers, all that kind of stuff. Plus, if like me, you're constantly plugging things in and out of these, trying them out, sticking meters and oscilloscopes on it and seeing what's going on, you're going to fry some stuff. Sometimes you will fry stuff on purpose, which I definitely do, just to see how much punishment it can take. Now, I understand the benefits of soldering in your chips, but how are you ever going to see how much punishment a driver can actually take and what its limits are if you know that when you push those to their limits and finally fry it, you're going to have to toss the board out or rig up some kind of like external breakout board or something like that. And if any of you out there say, well, the ecosystem and all of the soldered on components make for a better product, then I don't want to hear you say anything bad about Apple ever again. See what I'm saying? In addition to those things, since it's been adopted by Chinese manufacturing, it's available worldwide. It's supported in every firmware. All the accessories are cheap because it's developed to use our cheesy 16x4 LCD displays and all those kinds of things you can get at gadget shops that have been around forever. It's super simple to program because it uses the Arduino IDE, which we're already familiar with, and you just edit a couple files and upload it to your board, reset, and you're good to go. And while it does have a lot of problems, by now the problems are all very well known and the solutions are all very well known. They're still frustrating, don't get me wrong, and it annoys me every day when I can't just go online and find one board that's good. I'd love to be able to find a ramps board that's cheap, safe, and complete and be able to recommend it, but unfortunately you can't do that. But since it's so well known and well documented, it's fairly easy to troubleshoot and fix too, or modify for your particular needs. And if you screw up the mods, you're only out a $7 or $10 board. It's also open source, and that's very important. You have all the files available, and that's one of the reasons that the troubleshooting is so much easier. You can pull up the PC board data, you can pull up the schematics, you can look back through the version history, there's citations for all the problems they had, how they overcame it, so it's very easy for you as someone completely new coming into this like 5-10 years later to just open that up, look at it, and then solve the problems you're having. But when it comes down to it, it's good for the portions of the market that need flexibility and low cost, i.e. the makers, the developers, and people that are just trying to get their feet wet in 3D printing. And while you might say, oh, well, you can save money on an integrated board that has the processor on there, you can't say, okay, well, if the price of a Mega is 20 bucks, the price of a Ramps is 10 bucks, and the price of the drivers is like 15 bucks, and add all that up and put it all onto an integrated board. It doesn't apply with tinkers, experimenters, because at the end of the day, if they don't like it, they can pull those things apart and they still have fully functional LCD screens and stepper drivers for something else, as well as an Arduino that you can do all kinds of crazy stuff with. Now, what are the bad parts of it? Well, we all know about Spotty Quality. It's kind of that life is like a box of chocolate thing. Like, you're not sure what kind of Ramps board you're going to get. And unfortunately, the most important aspects of it, i.e. like the copper thickness, the ratings of the connectors and that type of thing, you rarely ever, if ever, get those on the online advertisements, and it's not until you get them in that you can actually test them or look at the tiny little imprints and see what exactly the ratings are, that you know what's going on. And that's one of the reasons that I reviewed as many of the cheapy Ramps boards as I could get a hold of in time for the first part of this video, because I had wanted people to see what some of the problems they might run into are and why, and give them the math on how they can get around it. But despite all that, the boards are still, they're showing their age, they're getting long in the tooth, and they're kind of insufficient for modern needs. We do a lot of like pin juggling and port shuffling and that type of thing. We don't quite have enough I/O. There aren't enough stepper sockets. It's meant for like getting a basic printer off the ground with some bells and whistles that you might need. And if you don't need those, you can remap them, etc., etc. But they do have limited expansion. You have 5 stepper slots, and unfortunately, some of the things that have become common, like the smart display connector adapters, they're for days gone past. We should have moved past like the 8-wire LCDs a long time ago and gone to like 2-wire SPI and that type of thing. But we haven't, and people are still using the first generation or first iteration of those types of boards that monopolize all of the pins on your back edge, and then 1 or 2 of the aux slots as well, including just covering up pins that aren't even used by the adapter. And that's just one of many known issues with the board. There were design issues. There's also the problem of people that are mass manufacturing these boards just not even following the basic specifications. And there are things that I think need to be upgraded, as in, these were originally made for a 12-volt ATX power supply that you would just pull out of an old broken down computer or something like that. 12 volts that'll get you a minimally functional computer, and you can kind of tweak it and massage it to get it working okay. But the fact of the matter is, we need to be running at higher voltage. And while that's possible on a lot of the Ramps boards where you can just pluck off a diode and you're good to go, some of them require a little bit more massaging to make that happen. And while it's nice that the boards are modular, we do have a problem that the step stick format is very small, like 3 square centimeters, I think, or something like that. So we don't have a lot of heat dissipation capabilities there, and we're limited to around like between 1.5 amps, maybe a little more of current that we can pump out to our steppers. And that kind of puts a soft limit on what we can do in terms of torque with our steppers, particularly if we're running at lower voltages. And that limits the size of the machines that we can do. And when people say the Ramps is out of date, you have to remember that the Ramps stands for RepRap Arduino Mega Pololu Shield. So it's not just the Ramps you have to worry about, it's also the Arduino Mega and the Pololu part. Because there's no reason we can't switch to a larger format for the modular step sticks that'll let us dissipate a little bit more heat and give us more space for headers to get to the features of some of these more modern driver chips. And then we have the limitations of the Mega itself. We all know how terrible, well, maybe we don't all know. I'll tell you now. The Arduino power supplies, I don't know who designed it, but it's just begging for like a chain reaction screw up from the jack all the way down to the CPU. Yeah, everything's dependent on not overheating that one regulator, and unfortunately the Ramps board is powered off of that one regulator, which is okay if you didn't have as many options to plug things in. But as it is, if you plug in a full graphics display with a backlight and all the other gizmos, you're going to be exceeding the dissipation limit of that chip. And that's another thing you have to go ahead and fix. And the way that those chips fail, unfortunately, I've had a lot of them fail in a voltage out v equals voltage in state. So if you're putting 12 volts in to a regulator that's supposed to knock it down to 5, that cascades into another regulator that's supposed to knock 5 down to 3, but it can only take 6 at the max, and you're trying to knock that down to put it on a 3-volt pin on your processor, all it takes is slipping with your screwdriver and shorting against something on your LCD board when you're trying to adjust the contrast with a little screwdriver. That pops your 5-volt chip. That puts 12 volts on your 3-volt chip that can only take 6 volts, which then puts 6 volts on your microprocessor, which blows a hole in it. They could have built in a failsafe, an indicator, a crowbar circuit, anything like that, but it just didn't happen. And then you also have the kind of bad connectivity. The USB is kind of quirky and slow. You know, if you've tried to do fast prints out of Pronterface over the USB, it doesn't always work out that well. But that all goes to show what some of the issues are for the Ramps Mega combination. Now, do I think it's going away? No, of course not. It is using kind of a legacy microprocessor, but the board designs are out in the wild, and we can still get them for like 10, 12, 15 bucks from China. So until all that's gone completely bye-bye, it's still going to be an option for us. And if you think, like, well, those mega chips are going to go away eventually, maybe. I could go out and for $5 buy a 6502 chip and build myself an old Commodore or an Apple II. That's an 8-bit microprocessor from 1975. So don't just sit there and hold your breath and say, oh, they're going to go away. You have to give people a reason to move on. You have to pull them out of it with either price or features or a combination of those two. Because otherwise, we're always going to be falling back to Ramps because it's sufficient for an entry-level Cartesian machine or an experimenter's platform. Now, as far as the Ramps Mega combo moving on to the next generation, there have been two big stumbling blocks there. One is Marlin 32-bit, and those folks are working really hard, and I don't fault them for it, and it is an open source project. Anybody who wants to can jump in and help. I'm just stating the fact here that if Marlin 32-bit were out a year or two ago, then we would already have moved on to a new platform. As it is, there's Smoothie and RepRap firmware and Marlin for Dua, and I don't know if Teacup has a 32-bit version. There's Repetier has a 32-bit version. But it's all kind of yeah, and those are still, sorry, other firmware developers, considered to be, by the average user, alternative firmwares. Also, the new Marlin is a little bit of a pain in the butt to get installed, compared to the old system, which just straight out of the Arduino IDE. But let's take the areas from the ramps that we should have kept and the areas we should have developed by now and see where that leaves us. So if we're talking about the RepRap Arduino Mega Pololu shield, well, we can either keep or leave the Pololu step stick format for something that dissipates a little bit more heat, or not, just keep the old one. But we can ditch the P part of ramps. And the AM, the Arduino Mega, obviously you're moving on from a Mega. Where are we going, though? Well, in 32-bit land, everybody's basically using ARM Cortexes. Now, clock speed doesn't matter all that much. It does, but not all that much. But our interrupt speed on our Mega is limited. So we're only going to be putting out like 16,000 pulses a second or so with the firmwares that we're using, unless we resort to dirty tricks. And the Mega's limited to integer math and bit twiddling and trickery, where we're moving onto platforms where we need a little bit more processor grunt, so that we don't have to worry about like how long it takes to compute an int versus a long. Delta stuff and Core XY stuff, they require a little bit more horsepower for the computations, and we have a whole lot more horsepower to throw around for other features when we move into 32-bit land. They also have improved USB handling, which is very nice, and built-in support for all the types of things that we had to like kind of kludge into the 8-bit processors. It's not just the Mega part of the Arduino Mega that we're having a problem with, it's also the Arduino part of it. The whole robotics world was holding their breath and waiting for that 32-bit Arduino board to come out. We were all so excited for it. I can remember like counting down the days until they would put something out. They finally gave us a new flagship model, the Duo. I'm going to call it the Duo. And that used a SAM Series Cortex-3 chip, and it fit in the Mega form factor. Yay, new flagship. It ended up not being very popular, and they actually discontinued it and then brought it back. What the world wanted was a board that they could just take and plug into their old Mega projects, use a new version of the IDE with 32-bit libraries, and everything would be happy. But instead, what we got was a board where they shuffled the pins around, so that made shields go bye-bye. None of them were 5-volt compliant, so all your externals and peripherals and sensors and everything, all of this mature technology from decades, all out the window, unless you want to use level shifting of some sort, or input-output buffering, or individual MOSFET level shift, whatever. That should have been all built into the board, if not the processor. They also lowered the current that's available from the pins, and it was already a bit sketchy. Made the power supply less capable, and they didn't put an EEPROM on it. So the nerd world kind of collectively said, keep it. Now, you can still get something like a ramps to work with a Duo. It takes a little figuring, though, and there was actually, as you probably know, a next generation of ramps planned by a couple guys, Bob C. and I forget the other dude. Off the top of my head, sorry, other dude. Which was just called the Ramp FD, the ramps for Duo. Unfortunately, that was kind of caught up in what you could call developer hell. That's what they would call it in the movie world. But in the open source world, it's kind of the too many cooks in the kitchen. Everybody wanted the next generation of that popular board to have their stuff on it, what they wanted on it, which is fine. But the problem is that Chinese manufacturing went ahead and they ran with an early version. It was full of bugs while they were still working out the hardware issues. So you can't actually buy a SAPE Ramps FD. They also met with a lot of resistance from particular community members that kind of fought them tooth and nail every step in the way over other things, or just threw stumbling blocks in the way and derailed conversations. Partially because sometimes people just kind of get dogmatic and act like that. And in other cases, these guys had a financial interest in a 32-bit ramps not happening. And there are some fine plug-in boards for the Duo, like the RADs, but the RADs, it's not GPL. It's Creative Commons NC, CCNC, non-commercial, so nobody else can make these and the price isn't going to come down. And that's fine. Why would they throw money out the window? So regardless, what we should have had instead of RAMPS was RADS, just a RepRap ARM driver shield. Now, are there alternatives out there that are pretty cheap? Yeah, sure they are. They just haven't been adopted by the Chinese mass market, blah, 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 and they're not widespread. But is that necessarily what we want? Because even though you might get the price down, you're always cheaping out on components, as is evidenced by the fact that we can't find a viable option right out of the box with the ramps board. So what can we do? Well, the options are make an acceptable Duo, which we've kind of done with the ReArm project. The only problem with that is it's very expensive and has not been adopted by Chinese manufacturing, so you can't get a cheap substitute because it's not a general computing platform, it's a very specific 3D printer platform, whereas the Arduino Megas are used by a lot of other things. Or we could wait for Arduino to pull their heads out of their butts and make the Duo that we should have had. Not going to happen, but I would call it the Duo NSV version, not stupid version, with remapped pins, more current, 5-volt tolerant I/O, and all that kind of nonsense. Not going to happen. We could redo ramps for Duo like it should have been, just straight up ramps as it is with the bad parts fixed that'll plug into a Duo, and that would not be all that difficult. You can, with a soldering iron and a knife, modify a ramps board to work on a Duo, but even if you had one that you didn't have to mod, you still have the problems of the non-compliant pins, the loss of some of your headers, the fact that the peripherals don't fit anymore, and all that nonsense. So that's why I said maybe drop the Arduino part off of it. There's no reason you couldn't run a 3D printer board off of something like and have I bought a fistful of these to mess around with? Am I going to build a 3D printer out of them? Darn right I am. So thanks for coming along with this series. I'll still be posting stuff for ramps, and I'll put them into this playlist as I go along. But I think I've hit on the major things. If you have any questions, leave them in the comments below. Or if you're just angry because I called out your business practices and you really think it's a good idea to get on the bad side of a death metal musician from Philadelphia, come at me, bro. I ain't hiding. If you have comments or suggestions, leave those too. If you like this kind of in-depth content and you'd like to see me continue this channel, I have support links down in the bottom, and I'm making these videos to help everybody in the community out. And those questions and comments and suggestions for topics, they help me find out what information is missing so that I can make videos to fill in those cracks in the knowledge. I don't want to cover the same things everyone else has covered just because they're popular, unless I think I can do it in more depth. So anyway, until the next video, get out there and make something awesome.